Okay, so now we're gonna move on to the number 10. So here we're gonna go from atoms to moles, or in other words, representative particles to moles. With that said, that means we're gonna revert back to our chart. That means we're gonna go from here to here, or from here to here. So make sure that we're using and understanding where these arrows are going, okay? So we're gonna move back to 10, okay? And number 10 says that we have how many moles of lead Pb are in 1.5 times 10 to the 12 atoms of lead. So what you're gonna do, sorry, let me kind of make it look better, I guess. No, did it? Can tell. So for number 10, you're given here is gonna be 1.50 times 10 to the 12th power atoms of lead. So, right, Pb. And what you're gonna try to solve for, what your one is the number of moles of lead, okay? So what you're gonna do is we're going from RP to moles. So if you look at our chart, oh my Jesus Christ. So if you look at our chart, we're going from RP and then we're gonna go to moles. So that means we have to divide by the molar, by Avogadro's number. So then we go back to here. And you're gonna set up your system, which is gonna be 1.50 times 10 to the 12th power lead atoms. And then you're gonna give me your dimensional analysis line, your chart, which nobody really likes because people don't like change. And then we have to use the relationship, right? Our conversion factor here is gonna be 6.02 times 10 to the 23rd RP, yeah? In this case, it's gonna be Pb atoms, right? Lead atoms is equal to 1 mole of lead, yeah? So then our job is to determine what goes on the top, what goes on the bottom, yeah? So which one of these is gonna go on the top and the bottom? Well, we have to match up our units, yeah? So because these have to be identical, Avogadro's number is gonna go at the bottom. And your 1 mole of lead is on top. Yeah, so then you're gonna use a calculator. Don't forget that if you're using the Apple calculator or the one through, or any calculator that you're using off your phone, make sure that you have the function EE. So what you're gonna do is you're gonna press 1.50 or 1.5, and then here you would press EE. EE to the 12th power, and then you're gonna divide by 6.02 times 10 to the 23rd power. And you should get the following: 2.49 times 10 to the negative 12 power moles of lead. And that's your answer.